Hello everyone, welcome to In 5 Minutes. In this video, we are going to see the next problem on gamma function type 3. So this is our question. We have to show that this integration is equal to this term. But before that, the basic formula of gamma of n is given by integration of 0 to infinity e raised to minus x raised to n minus 1 into dx. So we have to make this equation in this form. So if you see, we have e raised to minus ax term here and here. Here we have x raised to n minus 1. Here also we have x raised to n minus 1. Here we have cos bx and we do not have cos bx term. So what we are going to do? We don't want this cos bx term, but instead of cos bx term, we need some e raised to something. So we know that e raised to ibx is nothing but cos bx plus I times sin bx. So instead of cos bx, we can write it as a real part of e raised to ibx. That is, the real part of e raised to ibx is nothing but cos bx. So instead of cos bx, we can write as real part of e raised to ibx. Why we are not using here e raised to minus ibx? We can definitely use e raised to minus ibx, but here we already have e raised to minus ax term. So that's why we are not using e raised to minus ibx. So our integration will become integration of 0 to infinity x raised to n minus 1 e raised to minus ax, and instead of cos bx, we are going to write real part of e raised to ibx. Real part of I can take here, we get real part of integration of 0 to infinity x raised to n minus 1, and we can combine these two terms. If we combine these two terms, we get e raised to minus ax plus ibx. Here I am taking minus sign common and I am taking x common. So we get a minus ib into x. So these two terms after combining, we get e raised to minus a minus ib into x dx. Okay, so this is our new equation. So let's consider only this part for our analysis. Let's say this is our I1. So our I1 is this. If you compare this equation with our gamma function of n, here we have e raised to x term only. We do not have e raised to some constant and then x. So we need only e raised to x where power of x is 1. So this equation is of the type 1. In type 1, we used to substitute this term equal to some constant whose power is 1. So we substitute a minus ib into x equal to t. Then our x will be t upon a minus ib. Then dx will be dt upon a minus ib. Since we are changing the variable, our limits of integration will also get changed. Here we write initial variable is x and the new variable is t. X is from 0 to infinity, and when we put x equal to 0, we get t equal to 0. When we put x equal to infinity, we get t also equal to infinity. So this I1 will become integration of 0 to infinity. Instead of e raised to this term, we are writing as t. So e raised to minus t. Instead of x, we are writing t raised to a upon a minus b. So t upon a minus ib, the whole raised to n minus 1 into dx. What is dx? Dx is dt upon a minus ab. So this is our I1, which is only this part. So we can write this term as t raised to n minus 1 upon a minus ib, the whole raised to n minus 1. And here also we have a minus ib, so this is 1. So if we combine this term and this term, we get a minus ib the whole raised to n minus 1 plus 1, which will be a minus ib the whole raised to n into dt, and all the terms will remain as it is. A minus ib the whole raised to n is constant, so we can take this out of the integration sign, and inside we get integration of 0 to infinity e raised to minus t raised to n minus 1 dt. If you compare this part with the basic equation of gamma n, this is nothing but gamma of n. So our I1 is gamma of n upon a minus ib the whole raised to n. So if we substitute this term here, we will get our I. But we have to prove this part. So in this part, if you see, we do not have any I terms, so we have to get rid of the I term. So what we are going to do, we are going to take the complex conjugate of this term. So what is complex conjugate of a minus ib? It is a plus ib. Then what is the complex conjugate of a minus ib the whole raised to n? It will be a plus ib the whole raised to n. So we multiply and divide by a plus ib the whole raised to n upon a plus ib the whole raised to n. So how we are going to solve this equation?